Section 23 of National Geographic Magazine, Volume 3. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Height and Position of Mount St. Elias by Israel C. Russell. Laid before the Board of Managers, December 11, 1891. The height and position of Mount St. Elias have been measured several times during the past century with varying results. The measurements made prior to 1891 have been summarized and discussed by W. H. Dahl of the U.S. Coast and Geodetic Survey. The various results obtained are shown in the following table. With the exception of the position determined by Malaspina and the measurements of 1891, they are copied from Dahl's report. Height and position of Mount St. Elias. Date 1786. Authority La Perouse. Height 12,672 feet. Latitude 60 degrees 15 minutes. Longitude 140 degrees 10 minutes. Date 1791. Authority Malaspina. Height 17,851 feet. Latitude 60 degrees 17 minutes 35 seconds. Longitude 140 degrees 52 minutes 17 seconds. Date 1794. Authority Vancouver. Height left blank. Latitude 60 degrees 22 minutes 30 seconds. Longitude 140 degrees 39 minutes. Date 1847. Authority Russian Hydrographic Chart 1378. Height 17,850 feet. Latitude 60 degrees 21 minutes. Longitude 141 degrees. Date 1847. Authority Tebenkoff Notes. Height 16,938 feet. Latitude 60 degrees 22 minutes 36 seconds. Longitude 140 degrees 54 minutes. Date 1849. Tebenkoff Chart 7. Height 16,938 feet. Latitude 60 degrees 21 minutes 30 seconds. Longitude 140 degrees 54 minutes. Date 1849. Authority Barkan Inseln. Height 16,758 feet. Latitude 60 degrees 17 minutes 30 seconds. Longitude 140 degrees 51 minutes. Date 1872. English Admiralty Chart 2172. Height 14,970 feet. Latitude 60 degrees 21 minutes. Longitude 141 degrees. Date 1874. Authority U.S. Coast Survey. Height 19,500 plus minus 400 feet. Latitude 60 degrees 20 minutes 45 seconds. Longitude 141 degrees 12 seconds. Date 1891. Authority National Geographic Society Expedition. Height 18,100 plus minus 100 feet. Latitude 60 degrees 17 minutes 51 seconds. Longitude 140 degrees 55 minutes 30 seconds. The position given by Malaspina is from a report on astronomical observations made during his voyage, which places the mountain in longitude 134 degrees 33 minutes and 10 seconds west of Cadiz. Taking the longitude of Cadiz as 6 degrees 19 minutes 7 seconds west of Greenwich, the figures given in the table are obtained. The data from which the various determinations made previous to 1874 were obtained have not been published. The observations made by Messrs. Dall and Baker of the U.S. Coast and Geodetic Survey are published in full in the annual report of the Survey for 1875 already referred to. The observations made by myself last summer as a part of the work of an expedition sent to Mount St. Elias by the National Geographic Society and the U.S. Geological Survey, from which the height and position of the mountain have been computed, are as follows: a base line 16,876 feet long was measured on the beach at Icy Bay. The line, with the exception of sections C to D as shown below, was measured 3 times in sections of about 3,000 feet each. The distances given below in columns 1 and 2 were obtained with a 100-foot steel tape, and those given in column 3 with a 300-foot iron wire. These are rough measurements made without the use of a plumb bob and without taking account of temperature. The ground was quite smooth with a rise of about 5 feet in the center, but section C to D was crossed by a stream channel about 300 feet broad and 20 feet deep. Throughout much of the distance the ground was covered with grass, which was only partially cleared away. The stations at the ends of the line were 10 feet above high tide. The bearing of the line from the western base was south 89° east magnetic. Measurements of base line. Western base to station A, column 1, 3,179 feet 10 inches. Column 2, 3,178 feet 7 inches. Column 3, 3,178 feet 9 inches. Mean 3,179 feet 1 inch. Station A to station B, column 1, 2,355 feet 2 inches. Column 2, 2,354 feet 1 inch. Column 3, 2,354 feet 2 inches. Mean 2,354 feet 6 inches. Station B to station C, column 1, 3,589 feet. Column 2, 3,587 feet 9 inches. Column 3, 3,586 feet. Mean 3,587 feet 7 inches. Station C to station D, column 1 rejected. Column 2, 2,609 feet 2 inches. Column 3, 2,609 feet 5 inches. Mean 2,609 feet 3 inches. Station D to eastern base, column 1, 5,145 feet 5 inches. Column 2, 5,144 feet 10 inches. Column 3 not measured. Mean 5,145 feet 1 inch. Length of base line, mean 16,875 feet 6 inches. The measurements of angles were made with the gradient reading by Vernier to minutes. The error of the vertical arc was -3 minutes and remained constant during the observations. Instrumental observations. Measurements of angles at western base. 1. St. Elias to eastern base. Right Vernier 218° 35 minutes to 317° 6 minutes. Left Vernier 38° 35 minutes to 137° 7 minutes. Vertical angle +5° 40 minutes. Date 1891, August 14th, 10 a.m. 2. St. Elias to eastern base. Right Vernier 218° 34 minutes to 317° 6 minutes. Left Vernier 38° 37 minutes to 137° 7 minutes. Vertical angle +5° 40 minutes. Date same as last. 3. St. Elias to eastern base. Right Vernier 218° 37 minutes to 317 degrees 6 minutes. Left vernier 38 degrees 39 minutes to 137 degrees 8 minutes. Vertical angle +5 degrees 40 minutes. Date same as last. 4. St. Elias to eastern base. Right vernier 261 degrees 41 minutes to 0 degrees 10 minutes. Left vernier 81 degrees 43 minutes to 180 degrees 11 minutes. Vertical angle +5 degrees 40 minutes. Date same as last. 5. St. Elias to eastern base. Right vernier 261 degrees 41 minutes to 0 degrees 10 minutes. Left vernier 81 degrees 43 minutes to 180 degrees 10 minutes. Vertical angle +5 degrees 40 minutes. Date same as last. 6. St. Elias to eastern base. Right vernier 50 degrees 15 minutes to 148 degrees 45 minutes. Left vernier 230 degrees 15 minutes to 328 degrees 45 minutes. Vertical angle +5 degrees 40 minutes. Date 1891, August 14th, 6 p.m. 7. St. Elias to eastern base. Right vernier 50 degrees 15 minutes to 148 degrees 45 minutes. Left vernier blank. Vertical angle blank. Date same as last. 8. St. Elias to eastern base. Right vernier 181 degrees 5 minutes to 279 degrees 30 minutes. Left vernier 1 degree 5 minutes to 99 degrees 32 minutes. Vertical angle +5 degrees 40 minutes. Date same as last. Measurements of angles at eastern base. 1. St. Elias to western base. Right vernier 252 degrees 26 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 27 minutes to 356 degrees 19 minutes. Vertical angle +5 degrees 34 minutes. Date 1891, August 17th, 11:30 a.m. 2. St. Elias western base. Right vernier 252 degrees 26 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 26 minutes to 356 degrees 19 minutes. Vertical angle +5 degrees 34 minutes. Date same as last. 3. St. Elias to western base. Right vernier 252 degrees 25 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 26 minutes to 356 degrees 19 minutes. Vertical angle +5 degrees 34 minutes. Date same as last. 4. St. Elias to western base. Right vernier 252 degrees 26 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 27 minutes to 356 degrees 19 minutes. Vertical angle +5 degrees 34 minutes. Date same as last. 5. St. Elias to western base. Right vernier 252 degrees 26 minutes to 176 degrees 19 minutes. Left vernier 72 degrees 26 minutes to blank. Vertical angle +5 degrees 34 minutes. Date same as last. 6. St. Elias to western base. Right vernier 252 degrees 27 minutes to 176 degrees 20 minutes. Left vernier 72 degrees 28 minutes to 356 degrees 20 minutes. Vertical angle +5 degrees 34 minutes. Date 1891, August 17th, 2 p.m. 7. St. Elias to western base. Right vernier 252 degrees 28 minutes to 176 degrees 21 minutes. Left vernier blank. Vertical angle blank. Date 1891, August 17th, 4:30 p.m. From these observations, the following angles between the base line and the line of sight to the summit of Mount St. Elias are obtained. The correction for error of vertical circle has been applied to the angles of elevation. Resulting angles: western base 1. Right vernier 98 degrees 31 minutes, left vernier 98 degrees 32 minutes, corrected vertical angle plus 5 degrees 43 minutes. 2. Right vernier 98 degrees 32 minutes, left vernier 98 degrees 30 minutes, corrected vertical angle plus 5 degrees 43 minutes. 3. Right vernier 98 degrees 29 minutes, left vernier 28 degrees 29 minutes, corrected vertical angle plus 5 degrees 43 minutes. 4. Right vernier 98 degrees 29 minutes, left vernier 98 degrees 28 minutes, corrected vertical angle plus 5 degrees 43 minutes. 5. Right vernier 98 degrees 29 minutes, left vernier 98 degrees 27 minutes, corrected vertical angle plus 5 degrees 43 minutes. 6. Right vernier 98 degrees 30 minutes, left vernier 98 degrees 30 minutes, corrected vertical angle plus 5 degrees 43 minutes. 7. Right vernier 98 degrees 30 minutes, left vernier blank, corrected vertical angle plus 5 degrees 43 minutes. 8. Right vernier 98 degrees 25 minutes, left vernier 98 degrees 27 minutes, corrected vertical angle plus 5 degrees 43 minutes. Mean for right vernier 98 degrees 29 minutes 22 seconds. Mean for left vernier 98 degrees 29 minutes 0 seconds. Total mean 98 degrees 29 minutes 12 seconds, corrected vertical angle plus 5 degrees 43 minutes. Eastern base 1. Right vernier 76 degrees 7 minutes, left vernier 76 degrees 8 minutes, corrected vertical angle plus 5 degrees 37 minutes. 2. Right vernier 76 degrees 7 minutes, left vernier 76 degrees 7 minutes, corrected vertical angle plus 5 degrees 37 minutes. 3. Right vernier 76 degrees 6 minutes, left vernier 76 degrees 7 minutes, corrected vertical angle plus 5 degrees 37 minutes. 4. Right vernier 76 degrees 7 minutes, left vernier 76 degrees 8 minutes, corrected vertical angle plus 5 degrees 37 minutes. 5. Right vernier 76 degrees 7 minutes, left vernier blank, corrected vertical angle plus 5 degrees 37 minutes. 6. Right vernier 76 degrees 7 minutes, left vernier 76 degrees 8 minutes, corrected vertical angle plus 5 degrees 37 minutes. 7. Right vernier 76 degrees 7 minutes, left vernier blank, corrected vertical angle blank. Mean for right vernier 76 degrees 6 minutes 51 seconds. Mean for left vernier 76 degrees 7 minutes 36 seconds. Total mean 76 degrees 7 minutes 10 seconds. Corrected vertical angle plus 5 degrees 37 minutes. The known elements of the triangle from which the distance of St. Elias from the ends of the base line may be determined are: angle at western base 98 degrees 29 minutes 12 seconds, angle at eastern base 76 degrees 7 minutes 10 seconds, distance between western base and eastern base 16,876 feet. These data were sent from the field to the Secretary of the National Geographic Society, and, in connection with other measurements made at the same time, have been computed by Mr. S.S. Gannett of the United States Geological Survey. The results of the computation, so far as they relate to Mount St. Elias, are given below. Computation of the height of Mount St. Elias. Logarithm distance eastern base to western base 16,876 feet equals 4.227270. Station St. Elias, angle 5 degrees 23 minutes 38 seconds. AC logarithm sine equals 1.026862. Station western base, angle 98 degrees 29 minutes 12 seconds. Logarithm sine equals 9.995218. Station, Eastern Base, angle 76 degrees, 7 minutes 10 seconds, logarithm sine equals 9.987129. Logarithm distance St. Elias to Western Base equals 5.241261. Logarithm distance St. Elias to Eastern Base equals 5.249350. Next, logarithm distance St. Elias to Western Base equals 5.241261 logarithm feet, or 1.518627 logarithm miles, or 33.01 miles. And a logarithm tangent angle of elevation 5 degrees 43 minutes equals 9.000465, which gives us 4.241726, which is the logarithm 17,447 feet. Correction for curvature and refraction in feet equals 4/7 squared of distance in miles. Logarithm distance miles equals 1.51863. Logarithm 4 equals 0.60206. AC logarithm 7 equals 9.15490, giving us 2.79422, which is logarithm 623 feet. So 17,447 feet plus curvature and refraction 623 plus western base above sea 10 equals St. Elias above sea 18,080 feet. Next, logarithm distance St. Elias to East Base 5.249350 logarithm feet, or 1.526716 logarithm miles, or 33.63 miles. Logarithm tangent angle of elevation 5 degrees 37 minutes, 8.992750 longitude feet, giving us 4.242100, which is 17,462 feet. Correction for curvature and refraction in feet. Logarithm distant miles 1.526716, logarithm 4 0.602060, AC logarithm 7 9.154902, which gives us 2.810394, which is logarithm 646 feet. So 17,462 feet plus curvature and refraction 646 feet plus eastern base above sea 10 equals St. Elias above sea 18,118 feet. Mean elevation above sea level equals 18,099 feet, or in round numbers 18,100 feet. Mr. A. Lyndon Cole of the U.S. Coast and Geodetic Survey and Mr. S.S. Gannett have each computed the geographic position of Mount St. Elias using the azimuth and angle of elevation of the mountain obtained by the U.S. Coast Survey at Port Mulgrave in 1874 and the elevation given above. From these data the approximate position of Mount St. Elias was found to be latitude 60 degrees 17 minutes 51 seconds north, longitude 140 degrees 55 minutes 30 seconds west. The computation by which these results were obtained is given below. Computation of geographic position of Mount St. Elias. Azimuth, Port Mulgrave to Mount St. Elias equals 152 degrees 17 minutes 17 seconds. Difference azimuth minus 59 minutes 55 seconds plus 180 degrees equals azimuth Mount St. Elias to Port Mulgrave 321 degrees 17 minutes 22 seconds. Port Mulgrave latitude 59 degrees 33 minutes 42 seconds. Difference latitude plus 44 minutes 9 seconds equals Mount St. Elias latitude 60 degrees 17 minutes 51 seconds. Port Mulgrave longitude 139 degrees 46 minutes 16 seconds. Difference in longitude plus 1 degree 9 minutes 14 seconds equals Mount St. Elias longitude 140 degrees 55 minutes 30 seconds. Next, first term logarithm k, that is distance Mulgrave to St. Elias, equals 5.0183184 in logarithm meters. Logarithm cosine azimuth z 142 degrees 17 minutes 17 seconds equals 9.89822292 in logarithm meters. Logarithm b equals 8.50939002, which gives us 3.425938, which is the logarithm 2666.5 seconds. Second term k squared equals 0.0366 sine squared z equals 9.5731. Logarithm c equals 1.6335, which gives us 1.2432, which is the logarithm 17.6 seconds. Thus, first term plus 2666.5 seconds, second term minus 17.6 seconds equals the difference in latitude 2648.9 seconds. Next, logarithm k equals 5.0183184. Logarithm sine azimuth equals 9.786538. Logarithm a equals 8.508648. Arithmetical complement 60 degrees 17 minutes 51 seconds equals 0.30499593, giving us 3.61842553, which is the logarithm difference in longitude 4153.6 seconds. Thus, logarithm difference in longitude equals 3.61843. Logarithm sine mean latitude 59 degrees 55 minutes 46 seconds equals 9.93722, giving us 3.55565, which is the logarithm difference azimuth minus 3595 seconds. Note A, B, and C are terms depending on the size and figure of the earth and the latitude of the place. The geographic position of Mount St. Elias is of popular interest in connection with the boundaries of Alaska. In the convention between Great Britain and Russia, wherein the boundaries of Alaska are supposed to be defined, it is stated that the boundary beginning at the south after leaving Portland Channel shall follow the summit of the mountain situated parallel to the coast as far as the 141st meridian, and from there northward the said meridian shall be the boundary to the Arctic Ocean. Whenever the summit of the mountains between Portland Channel and the 141st meridian "shall prove to be at the distance of more than 10 marine leagues from the ocean, the limit between the British possessions and the line of coast which is to belong to Russia, above mentioned, shall be formed by a line parallel to the windings of the coast, and which shall never exceed the distance of 10 marine leagues therefrom." As Mount St. Elias is approximately in longitude 140 degrees 55 minutes 30 seconds west from Greenwich, as already shown, it is therefore only 4 minutes and 30 seconds of longitude, or 2½ statute miles east of the boundary of the main portion of Alaska. Its distance from the nearest point on the coast is 33 statute miles. There is no coast range in southeastern Alaska parallel with the coast within the limits specified by the treaty, and the boundary must therefore be considered as a line parallel with the coast and 10 marine leagues, or 34½ statute miles, inland. The mountain is thus 1½ miles south of the boundary and within the territory of the United States. Its position is so near the junction of the boundary separating southeastern Alaska from the Northwest Territory with the 141st meridian that it is practically a corner monument of our national domain. End of section 23.